Let's take a look at the answers to exam 1X. Problem 1, solve this equation. So first off, I'm going to start by distributing the 3 and then the 3 here. Distribute the 2. It's a linear equation, so I need to get all the q's to the left and all the numbers to the right. So first let me simplify the left side. 15q plus 6q is 21q. Minus 21 plus 10 is negative 11. Now I'm going to move the q's over. So negative 2q from the right comes over to the left, adds to the 21q and makes 23q. Negative 11 moves to the right, adds to the 9 and gives me 20. Divide both sides by 23, and we get q is equal to 20 over 23. So the solution set is 20 over 23. Next, let's look at problem 2. Solve this equation. So first, you'll notice that if you factor the denominator, you get the exact two linear factors that are on the left-hand side. So what we're going to do here is multiply both sides by x minus 5 times x minus 7. Next, we will distribute both x minus 5 and x minus 7 to these two terms on the left side. So we get x minus 5 times x minus 7 times 2 over x minus 5 minus x minus 5 times x minus 7 times 3 over x minus 7 equals. I'm going to go ahead and simplify the right side because I'm running out of room. The x minus 5 cancels, the x minus 7 cancels, and so the only thing on the right side is 11. Let me cancel the terms on the left side, x minus 5 and x minus 7. This leaves me with 2 times x minus 7 minus 3 times x minus 5 is equal to 11. Distribute the 2 and distribute the 3. So we have 2x minus 14 minus 3x plus 15 is equal to 11. We combine all the x's on the left. That gives me negative x. And we'll move the numbers to the right. On the left side that would be positive 1, so it moves over to the right side as a negative 1. 11 minus 1 is 10. Divide both sides by negative 1, and you get x is equal to negative 10. So the solution set is negative 10. Let's look at problem 3. Identify the equation as a conditional equation, a contradiction, or an identity, then give the solution set. So let's just start to work this out. This is 8x, distribute the 5, you get negative 5x minus 35 is equal to 2x minus 10 plus x minus 28. Simplifying the left side, we get 3x minus 35 is equal to 3x minus 38. Notice that we have 3x on both sides, so they cancel. And that leaves me with negative 35 is equal to negative 38. That is false. Since this equation is false, that means we have a contradiction. And the solution set to all contradictions is the empty set. Problem 4, simplify completely. Show your work. So in problem A, what I would do is I would do 79 divided by 4 that is equal to 19 with a remainder of 3. Since it's a remainder of 3, we know that I to the 79th power is the same thing as I cubed, and from the chart in class, we know that I cubed is negative I. Part B, multiply out these two complex numbers. So I'm going to distribute the 3 and get 6 plus 21i. Distribute the negative 5i, so you get negative 10i minus 35i squared. Here, the i's can combine. 21i minus 10i is 11i. Recall that I squared is equal to negative 1, so this becomes negative 35 times negative 1. And this would then be positive 35. So positive 35 and 6 is 41. On part C, when you divide two complex numbers, you want to multiply by the conjugate of the denominator. So the conjugate of the denominator is 2 minus 5i. So we'll multiply out the top. 1 times 2 is 2, 1 times negative 5i is negative 5i. Negative 3i times 2 is negative 6i. Negative 3i times negative 5i is positive 15i squared. For the bottom, 2 times 2 is 4. 2 times negative 5i is negative 10i. 5i times 2 is positive 10i. And then positive 5i times negative 5i is negative 25i squared. Notice that the I terms in the denominator cancel. Let's simplify the top. This is going to be 2 minus 11i plus 15 times negative 1 divided by 4 minus 25 times negative 1. That gives me 2 minus 11i minus 15 over 4 plus 25. So this is equal to negative 13 minus 11i over 29. And finally, we want to write this as a complex number. So we have to split up the fraction. It's negative 13 over 29 minus 11 over 29i. Let's look at problem 5. Solve for t. So first I'm going to move the 75 to the right side. Next, divide by 3. And then we're going to take the square root of both sides. When we do that, we get t on the left. And then the square root of negative 25 is 5i, and we use plus or minus. So the solutions here are plus or minus 5i. Problem 6. Solve by completing the square. So first, I'm going to factor out 2 from the first two parts, the x squared and the x. I'm going to leave a blank. We're going to do plus 5 and the blank is equal to 0. Next, I need to complete the square on this middle part. So we're going to take 1/2 of 6 is equal to 3. Take 3 squared, and that's equal to 9. So I'm going to write a 9 right there. But recall that the 2 is going to distribute to the 9. And so what I actually need to subtract is 18. 2 times 9. Factor, we get 2 times x minus 3 squared minus 13 equals 0. Next, we want to solve for x. So I'm going to move the 13 to the right side. Divide by 2. Take the square root. Use plus or minus. And then move the 3 to the right side. So the solution set is 3 plus or minus the square root of 13 over 2 inside the square root. And problem 7. Solve using any method. Well, the first thing I notice about this one is I have a lot of fractions. So I'm going to compute the LCD, or just any CD. I'm going to do 3 times 4 times 5, which is 60. So if I multiply both sides by 60, that will get rid of the denominators and fractions entirely. Now the 60 distributes, and 60 times 1/5 is 12, so we get 12m squared, minus 2/3 of 60 is 40, so we get 40m, is equal to 1/4 of 60 is 15. So looking at the equation, we have a quadratic. To solve a quadratic, the first thing you have to do is move everything to one side. So I'm going to move the 15 to the left. And then I'm going to use the quadratic formula. So m is equal to 40 plus or minus the square root of 40 squared minus 4 times 12 times negative 15 divided by 2 times 12. This is equal to 40 plus or minus the square root of 2,320 divided by 24. Next, we want to simplify the square root. So you look for perfect squares that would go into 2,320. And use your calculator, you get 16 times 145. 24. The square root of 16 is 4. Factor out a 4 from each of those terms. So we're going to get 10 plus or minus the square root of 145 divided by 24. Cancel off the 4, and that leaves a 6 in the denominator. So the result is 10 plus or minus the square root of 145 divided by 6. Question 8. Suppose the discriminant of a quadratic equation is negative 49. What does this information tell you about the solutions to this quadratic equation? Well, recall in class that we had this chart that told us what the nature of the roots were given the different types of discriminants. If it's positive, that means there are 2 real solutions. If the discriminant is 0, that means there is 1 real solution. And here, if the discriminant is negative, that tells us that there are 2 imaginary solutions. That's it. Question 9. Solve for p. When you have the absolute value of something equal to a number, you immediately split it up and you do 3p minus 1 is equal to the positive version of the number on the right, and then or 3p minus 1 is equal to the negative version of the number on the right. In this case, negative 17. Solve these equations independently. So we get 3p is equal to 18, so p is equal to 6. And then 3p is equal to negative 16, so p is equal to negative 16 over 3. So the solution is 6 comma negative 16 over 3. Question 10. Solve for x. Well, this one looks like a grouping problem. So first I'm going to group the first two terms together, and then I'm going to group the last two terms together. Then I'm going to factor out as much as I can from the first group. I see that I can factor out x squared. That leaves x minus 2. From the second group I can factor out 9, and that also leaves x minus 2. So now, taking the x minus 2, I can factor that out in front, and that leaves behind the x squared plus 9. Take these two factors, split them up, set them equal to 0. So x minus 2 equals 0 gives me the solution x equals 2. Taking x squared plus 9, setting that equal to 0. To solve for x, I move the 9 to the right. That becomes negative 9. Take the square root of both sides. The square root of negative 9 is 3i. And because it was x squared, we're going to use plus or minus. So the solutions here are 2, positive, negative 3i. Alright, let's look at question 11, solve for q. So I'm going to move the 7 to the right, that adds to 13 and gives me 20. Divide both sides by 5, that gives me 4. Raise both sides to the reciprocal of this power, which is 3/2. That leaves me with q, and if you plug in 4 raised to the 3/2 in the calculator, you get 8. Because the original power was a 2, and that's even, we need to use plus or minus on our answer. So the solution set is plus or minus 8. Let's take a look at problem 12. Solve for y. So we have a square root, so the first step is to isolate the square root. So we're going to leave it on the left, and then we're going to write that better. Then we're going to move the y to the other side. The next step is to square both sides. So squaring a square root just gives me the inside. Squaring 11 minus y gives me 121 minus 22y plus y squared. We have a quadratic, so I'm going to move everything to the right side. We're going to leave 0 on the left. This becomes y squared. 22y minus 2y is negative 24y. 121 minus 13 is 108. This factors, and it factors as y minus 6 times y minus 18. Split that up and you get y equals 6 and y equals 18. You do need to check these, and I'll leave it to you to check, but when you check y equals 6, that one works out, and when you get y equals 18, that one does not check out. So the solution is just 6. Problem 13, solve for r. So I'm going to use substitution. We're going to say r is equal to, u is equal to r to the 1/3. So this is r to the 1/3 squared minus 7 times r to the 1/3 is equal to 8. Now I'm going to substitute the u, so it's u squared minus 7u is equal to 8. I have a quadratic. Move everything to the left. That gives me u squared minus 7u minus 8 is equal to 0. And you get u and u, 8 and 1, minus and plus. Split up these factors, set them equal to 0, and solve for u. So u plus 1 is equal to 0 means u is equal to negative 1. u minus 8 is equal to 0 means u is equal to 8. Back substitute what u is equal to. So from above, u is equal to r to the 1/3 power is equal to -1, and r to the 1/3 power is equal to 8. To solve for these, I'm going to raise them to the third power. It's the reciprocal of the exponent. And these give me r is equal to -1 and r is equal to 512. So the solution set is -1 and 512. Let's solve this inequality. State the answer in both interval notation and set builder notation, and then graph on the number line. So I'm going to start by distributing the 3. Then I'm going to combine the x's on the left. Next, I'm going to move the 2x from the right to the left. That comes over as a negative, combines with the 1x there and gives me -x, which is less than, and then we have -5 on the right, and -3 on the left. If we move that over, we get -2. Then we want to divide both sides by -1, so we get x and 2, but also recall that when you divide by a negative with an inequality, you have to switch the signs around. So in interval notation, this would be 2, infinity. In set builder notation, it would be the set of x's such that x is greater than 2. And on the number line, this would be the open parenthesis at 2, and we would shade the right side of the graph. Next, let's look at problem 15. Solve the inequality. State the answer in both interval and set builder notations and graph. So to start this one, I'm going to distribute the 8. So we're going to get 24x plus 40 is greater than or equal to 24x minus 6. Notice that we got 24x on both sides, so those cancel. And that leaves me with 40 is greater than or equal to -6, which is true for all values of x. So we're going to get all real numbers, or you could use the real number notation here. There's not really a set builder notation. You could say, if you wanted to, x such that x is any real number, or you could say x such that x is in the reals, any of those. But the line would just be the entire line here, so just draw the line. Like so. And it's every real number. Alright. Let's look at 16. Solve the inequality. So this is one with absolute value, so you need to open it up. This is what I call opening the gate. All right. So -23 is less than or equal to 4x minus 17 is less than or equal to 23. Let's add 17 to all three sides. And so it's going to give me 6, -6 right there. It's less than or equal to 4x is less than or equal to 40. And then we're going to take that and divide all three parts by 4. So we get 10 on the right and -3/2 on the left. So this one is closed on the left end, -3/2 to 10 closed on the right end. In set builder notation, this would be the set of x's such that -3/2 is less than or equal to x is less than or equal to 10. And for the number line, we need to start at -3/2. That's -1.5. And it goes up to 10. And it's closed at 10. And I'll do the line again, like so. Alright. let's look at the application problems. So the first one was a mixture saline solution mixture problem. A scientist has 2.4% saline solution and 7.75% saline solution. How much of each solution should be added together to make 5 liters of 4.25% saline solution? So we want to draw the table. So we're going to have solution 1, solution 2, and the mixture. And we're going to use the amount, the concentration percentage, and then it's a saline solution, so that would be the amount of the salt. Alright, so for the first concentration, we're going to use the 2.4%, so that's 0.024. And the second one will be the 0.775 concentration. The resulting mixture should be 0.0425, 4.25%. To determine the amounts, I'm going to say we're going to use X of solution 1. I need a total mixture that has 5 liters, so that leaves 5 minus X for the second solution. And with that, I can define the variable. X is equal to the amount of 2.4% solution. Now remember that you can multiply this table going across. So X times 0.024 is 0.024X. Next would be 0.0775 times 5 minus X. And then 0.0425 times 5. And from this, we have the equation. We're just going to add the amount of salt from the first solution and the amount of salt from the second solution to equal the amount of salt in the mixture. So 0.024x plus 0.0775 times 5 minus x is equal to 0.0425 times 5. If I distribute, I get 0.024x plus 0.3875 minus 0.0775x is equal to 0.2125. Move all the x's to the left. We have negative 0.0535x is equal to, move all the numbers to the right, negative 0.175, and then divide both sides by the coefficient for the x, and we get 3.271 liters. So if x is the amount of the 2.4% solution, that means we need 3.271 liters of 2.4% solution. And then if you take 5 minus this 3.271, you get 1.729 liters of the second solution, which was the 7.75% solution. Next, let's look at the question 18. Lisa and Bart live 5 miles from each other. Lisa can ride her bicycle at 12 miles per hour. Bart can walk at 3 miles per hour. If Bart leaves his house 6 minutes after Lisa leaves her house, and they are headed toward each other, how far from Bart's house will they meet? Okay, so let's start with Lisa and Bart and the total. And this is a rate times time equals distance problem. Okay. Lisa's rate is 12 miles per hour. Bart's rate is 3 miles per hour. I'm going to say that Lisa is going to ride her bicycle for t hours. So now I can define the variable. T is equal to time Lisa rides bike in hours. Now we know that Bart leaves his house 6 minutes after Lisa. That means Bart is going to be traveling for a total time that is 6 minutes less than what Lisa travels. So that means Bart's time is going to be t minus, and now we have to be careful with the units. The 6 was 6 minutes, not 6 hours. So we need to change this to hours, and so it's t minus 6 over 60. Now I'll use the distance is equal to rate times time formula, and I just multiply across. So we have 12t, we have 3 times t minus, I'll reduce this to 1/10. And then we know that this total has to be 5 miles. And there we go. We're going to add the distance that Lisa rides with the distance that Bart walks, and that total is going to be 5 miles when they meet each other. So 12t plus 3 times t minus 1/10 is going to equal 5. Distribute the 3. You get 3t minus 3 over 10 is equal to 5. I have a fraction. I'm going to multiply everything by 10 to get rid of the fraction. So we have 120t plus 30t minus 3, because the 3 times 10 just cancels off the denominator, is equal to 50. On the left side, I get 150t. I move the 3 to the right, I get 53. And so this is t is equal to 53 over 150, and the t was in hours, so it's hours. Now that is not what the question is asking for, but we do need this in order to answer the question. The question was, how far from Bart's house will they meet? Well, that's the same thing as saying, how far did Bart travel when they met? Because Bart's leaving from his house. So, I'm going to use this formula for Bart's distance. And that will tell me how far Bart walked. So we're going to have distance is equal to 3 times 53 over 150 minus 1 over 10. And if you put that into the calculator and work it out, you get 0.76 miles. Alright, let's look at question 19. The hypotenuse of a right triangle is twice the length of the shorter leg. The longer leg is 4 centimeters longer than the shorter leg. What are the dimensions of the triangle? So, draw the picture. It's a right triangle. So we know the hypotenuse is twice the length of the shorter leg. So I'm going to go ahead and declare x to be the shorter leg length. And now the hypotenuse is 2x. The longer leg is 4 centimeters longer than the shorter leg, so that's just x plus 4. Now it's a right triangle, so we're going to use the Pythagorean Theorem. And we will have x squared plus x plus 4 squared is equal to 2x squared. And I'm just going to solve this for x. So we get x squared, multiply out x plus 4 squared, that's x squared plus 8x plus 16. 2x squared is 4x squared. It's not 2x squared. The 2x is the entire quantity being squared, not just the x. So it's got to be 4x squared. All right, move everything to the left. I have 2x squared on the left and 4x squared on the right. When that comes over, it comes over as negative 2x squared in total, plus 8x plus 16 equals 0. You could work with it like this. I prefer to multiply everything by negative 1 to get rid of the negative lead coefficient. So that just changes the sign of everything. It's the same thing as moving everything to the other side of the equation as well. So now we have 2x squared minus 8x minus 16. And to solve that, I'm going to use the quadratic formula. So this would be 8 plus or minus the square root of 8 squared minus 4 times 2 times negative 16 over 2 times 2. This was an application problem, so you can use your calculator and you can come up with the answer of 5.464 centimeters. The other answer is negative and doesn't count. And then the rest of the question was, what are the dimensions? So this was the x, that was the shortest leg. Then add 4 to get the longer leg. And then double the original one to get the hypotenuse. And those are the three answers that you should have gotten for this one. Finally, let's look at problem 20. The height in feet of an object that is tossed straight up from an initial height of h naught feet at an initial velocity of v naught feet per second is given by h is equal to negative 16 t squared plus v naught t plus h naught, where t is the number of seconds since the object was tossed. A ball is tossed straight up from atop a building that is 80 feet tall with an initial velocity of 10 feet per second. The ball is tossed in a way so that it is over the edge of the building and is allowed to fall to the ground. Question A. Write the model equation of the height of the ball after t seconds. So this would be h is equal to negative 16 t squared plus, now we look for the initial velocity, which is 10 feet per second, so it's 10t, plus, now we look for the initial height, which was 80 feet. So there's the model for the height of the ball after t seconds. Question B. What is the height of the ball after 2 seconds? So we're going to let t be equal to 2, and we're going to plug that in to the model. And when you work that out, you get 36 feet. And then question C. After how many seconds will the ball hit the ground? So the ball will hit the ground when h is equal to 0, because the height is h, and if it's the ground, then the height is 0. So we're going to set this equal to 0, so negative 16 t squared plus 10t plus 80 is equal to 0. Use the quadratic formula. T is equal to negative 10 plus or minus the square root of 10 squared minus 4 times negative 16 times 80 divided by 2 times negative 16. Work that out. One of the answers doesn't make sense. The other one is 2.570 seconds. Let's look at the answers for exam 1Y. Question 1, solve this equation. So I'm going to start by distributing the 2. You get 6c minus 14 minus 5. Distribute the 6, 6c plus 66. Combine the c's on the left here, so that's going to be 15c. Combine the numbers, it's going to be minus 19. It's equal to 6c plus 66. Move the c's from the right to the left. The 6c comes over as a negative, adds with the positive 15c and creates 9c. The 19 from the left is negative there. It moves over to the right as a positive, adds to the 66 and gives me 85. Divide both sides by 9 and you get 85 over 9. And so the solution is 85 over 9. Question 2, solve the equation. So first, I'm going to factor this bottom part. And it factors as x minus 3 times x plus 1. Those are the exact two factors in the other two parts of the fraction. So what I'm going to do is I'm going to multiply both sides of this equation by those two factors. Oops, do that in blue. Oh. On the left side, I'm going to distribute these two factors to both of these two terms. So that gives me x minus 3 times x plus 1 times 5 over x plus 1 minus x minus 3 x plus 1 times 4 over x minus 3. On the right side, I'm going to go ahead and cancel. So we have x minus 3, x minus 3, x plus 1, x plus 1. And that leaves me with just 12. Next, I'm going to cancel the factors on the left side. So we have x plus 1, and we have x minus 3. That leaves me with 5 times x minus 3 minus 4 times x plus 1 is equal to 12. Distribute the 5, so we get 5x minus 15 minus 4x minus 4 is equal to 12. 5x minus 4x is x. Minus 15 minus 4 is minus 19. That's equal to 12. Move the 19 to the other side, and we get x is equal to 31. So the solution is just 31. Question 3, identify the equation as a conditional equation, contradiction, or identity. So we're going to distribute the 12. It's going to give me 12x minus 24. Distribute the negative. That's going to give me negative 5x plus 1 is equal to 3x plus 3 plus 4x plus 36. Add the x's together on the left side. So 12x minus 5x is 7x. Add the numbers together. Negative 24 plus 1 is negative 23. Add the x's together on the right side. 3x plus 4x is 7x. 3 plus 36 is 39. The 7x's cancel. And that leaves me with negative 23 is equal to 39. That's false. And so we have a contradiction. And the solution to a contradiction is the empty set. Question 4, simplify completely. So to do part A, I to the 111th power, would take 111 divided by 4, and that is equal to 2 and 7 with a remainder of 3. So it's 27 with a remainder of 3. The important part here is the remainder 3. That tells me that I to the 111 is the same thing as I cubed, and from our table we know that I cubed is negative I. Part B, I'm going to multiply by the 4, so we're going to get 12 plus 28i. I'm going to multiply by negative I, give me negative 3i minus 7i squared. First, I'm going to combine the I parts, so that's going to be 25i. The I squared, recall, that changes to negative 1, so this is going to be positive 7. Positive 7 plus 12 is 19, plus 25i. Part C, to divide two complex numbers, we are going to multiply both the top and the bottom by the conjugate of the denominator. The conjugate of 9 plus 2i is 9 minus 2i. And so we multiply out the top, so 5 times 9 is 45, 5 times negative 2 is negative 10i, negative 2i minus 9 is negative 18i, and negative 2i times negative 2i is plus 4i squared, over 9 times 9 is 81, 9 times negative 2i is negative 18i, 2i times 9 is positive 18i, 2i times negative 2i is negative 4i squared. Let's simplify the top and the bottom. So we're going to have 45 minus 28i. The 4 times negative, the 4 times I squared becomes negative 4. And then we'll do the same thing similarly here on the bottom. The 18i's cancel. That leaves me with 81 plus 4. So together this gives me 41 minus 28i over 85. And we need to write that as a complex number. So it's 41 over 85 minus 28 over 85i. Question 5, solve for Q. I'm going to move the 14 to the right side. It goes over as a negative. Divide both sides by 7. It becomes negative 2. Now if Q squared is equal to negative 2, I want to take the square root of both sides, and that's going to give me Q is equal to plus or minus. The negative under the square root comes out as an I, but then you can't simplify the square root of 2. So it comes out as I root 2. And then it's plus or minus. So the solutions are plus or minus I root 2. Question 6, solve for x using complete the square. So the first thing I need to do is factor out the 3. That leaves x squared minus 4x plus blank plus 5 blank. Recall that we don't factor it out from the constant term. Complete the square on the 4, so it's going to be 1/2 of 4 is 2, 2 squared is equal to 4. So we are going to add 4 here, but we're actually going to subtract 12, because the 3 is going to multiply by the 4, and so we're going to actually add 12 to the equation. Since I'm adding 12 to the equation, I also need to subtract 12 from the equation. This piece now factors as 3 times x minus 2 squared minus 7 equals 0. To solve this, move the 7 to the right side. Divide by 3. Take the square root. And then finally move the 2 to the right side. So the solutions are 2 plus or minus the square root of 7/3. Let's look at problem 7. Solve using any method. The first thing I notice is it is a quadratic. It has p squared. Next, we notice that we have fractions. So I'm going to multiply by the LCD. The LCD of 4 and 5 is 20. So we're just going to multiply by 20 on both the left and the right. This will eliminate the fractions. Distribute the 20 to both the first term and the second term. 20 times 1/4 is 5. So we have 5p squared. 20 times 1/5 is 4. 4p. 20 times 2/5 is 8. We still have a quadratic, so the way we solve a quadratic is to move everything to the left. This probably doesn't factor. It's my intuition. And so I'm going to use the quadratic formula. So we get 4 plus or minus the square root of 4 squared minus 4 times 5 times negative 8 over 2 times 5. This is then equal to 4 plus or minus the square root of 176 divided by 10. 176 can be factored as 16 times 11. So remember, the key there is to pick off a perfect square and then a non-perfect square. So then the square root of 16 is 4. The 11 is the non-perfect square, so it stays under the radical. Factor out a 2 from the top and the bottom. Cancel the 2's, and then the remainder is the answer. So 2 plus or minus 2 square root 11 over 5, and that's the solution. Question 8. Suppose the discriminant of a quadratic equation is positive 7. What does this information tell you about the solutions to this quadratic equation? Well, we had this chart in class that said if the discriminant was positive, it's this, if it's 0, it's that, and if it's negative, it's this other thing. When the discriminant is positive, that means we have 2 real solutions. And that's it. Question 9. Solve for t. The absolute value of 2t plus 9 is equal to 79. When you have the absolute value is equal to a positive number, you immediately split it up into 2 parts. 2t plus 9 is equal to 79, or 2t plus 9 is equal to negative 79. And then you solve each part. So we get 2t is equal to 70, and t is equal to 35, or 2t is equal to negative 88, and t is equal to negative 44. So the 2 solutions are 35 and negative 44. Question 10. Solve for y. Well, this one looks like a problem that we would use grouping on. So I'm going to go ahead and group it into 2 parts. And then I'm going to see what I can factor from the first part and what can I factor from the second part. From the first part, y squared factors. That leaves me with y squared times y minus 7. From the second part, I can factor out negative 4. And that leaves me with y minus 7 equals 0. So notice we have y minus 7 as a factor in both parts. So that comes out, and it leaves me with y squared minus 4 equals 0. Split these up, and we get y minus 7 equals 0, which gives me y equals 7. And over here we have y minus 4 equals 0, which is y squared equals 4, which is y is equal to plus or minus 2. So the solutions are 7, 2, and negative 2. Or you could have written it as 7 and plus or minus 2. Alright, let's look at problem 11, solve for m. So first, I'm going to move the 25 to the right side. That becomes 243. And then I'm going to raise both sides to the reciprocal of the exponent, 7/5. So that's m, and then 243 raised to the 7/5 is 287. Since the original power was odd, we don't need to change by adding the plus or minus. It just is the answer that it turns out to be. So the solution is 2,187. Let's look at question 12. Solve for big B. So square root of 6b plus 1, then plus b is equal to 9. Step 1 is to isolate the radical. So square root of 6b plus 1, move this b to the other side, and you get 9 minus b. Now square both sides. You get 6b plus 1 is equal to 81 minus 18b plus b squared. We have a quadratic, so move everything to the right side, since that's where the b squared is. 6b comes over, and that makes negative 24b. The 1 comes over and makes positive 80. Factor. We get b minus 4, b minus 20. Set each of these equal to 0. So we get b equals 4, b minus 20 equals 0, so that's b equals 20. Now, because you did the squaring, you can end up with extraneous roots, so you do need to check. And I'll leave it to you to check that the 4 works, but that the 20 does not. So the solution is just the set 4. Problem 12. Solve for n. So this one, notice that we have the same pieces in 2 places. That's a big hint that we should use substitution. So I'm going to let u be equal to n squared plus 6n. With that the case, then this equation becomes u squared plus 2u minus 63 equals 0. This factors as u and u, 9 and 7, plus 9 and minus the 7. Set each of these factors equal to 0. We get u is equal to 7. Here we have u plus 9 is equal to 0, so u is equal to negative 9. Now, these u answers, these are not the answers we want. We are solving for n. So now we back substitute what the u was. So this is n squared plus 6n is equal to 7. And over here, n squared plus 6n is equal to negative 9. Let me solve the one on the left. So we have n squared plus 6n minus 7 is equal to 0. So that's n plus 7 and n minus 1 equals 0. So that gives me n is equal to negative 7 and n is equal to 1. On the right side, we're going to have n squared plus 6n plus 9 is equal to 0. That one factors as n plus 3 squared. That's a perfect square trinomial. And so the only answer we get here is n is equal to negative 3. So the solutions are negative 7, 1, and 3. That's negative 3. All right, question 14. Solve the inequality. So we're going to have 2x plus 3x minus 6 is greater than x plus 9. It'll be 5x minus 6 is greater than x plus 9. And that's 4x is greater than 15. So x is greater than 15 over 4. When we write that in interval notation, that would be 15/4 to infinity. Open it 15/4. When we write it in Set Builder, that's x such that x is greater than 15/4. 15/4 is between 3 and 4, just shy of 4. And so this is going to be right here. Up there. And to infinity. Question 15, solve the inequality. So distributing, we have 12x plus 28 is less than or equal to 12x minus 6. So we get 28 is less than or equal to negative 6. That is false. So we have the empty set as the answer, and we do nothing to the number line. There are no solutions. Solve the inequality. State the answer in both interval notation. All right. So here for this absolute value inequality, we're going to split off the absolute value, and we're going to have 3x minus 23 is greater than or equal to 4, or 3x minus 23 is less than or equal to the negative version of that number, negative 4. And then we just solve both of these separately. So we're going to get x is greater than or equal to 9, or 3x is less than or equal to 19, so x is less than or equal to 19/3. In interval notation, this would be negative infinity to 19/3 union 9 to infinity. In set builder notation, this would be the set of x's such that x is greater than or equal to 9, or x is less than or equal to 19/3. And on the number line, 19/3 is just a little bit over 6. So it would be right here. And we would shade in all of this going backwards, because x is less than or equal to that. And x is greater than or equal to 9 right there. And we shade in all that. All right, let's take a look at the application problems. Number 17, a scientist has 5.6% saline solution and 8.25% saline solution. How much of each solution should be added together to make 40 liters of a 6% saline solution? All right, so I'm going to start with the table. So we're going to have solution 1, solution 2, and the mixture. We'll have the amount right here, the concentration percentage, and then since it's a saline solution, this is amount of salt. So we need a total of 40, and I don't know how much of each, so I'm going to do x and 40 minus x. So right away I can go ahead and do this, define the variable part. X is equal to the amount of 5.6% solution. And since that is 5.6%, it's going to be 0.056 and then 0.0825. The entire mixture needs to be a 6% solution, so 0.06. Now, the amount of salt is equal to the amount that we're using times its concentration multiplied together. That gives us the amount of the salt. So I'm just going to multiply here from left to right. So we're going to get 0.056x. 0.0825 times 40 minus x. And then 40 times 0.06 is 2.4. So next, me create some space here. So next I want to write the equation, and the equation is simply this first amount of salt plus the second amount of salt is equal to the total amount of salt. So 0.056x plus 0.0825 times 40 minus x is equal to 2.4. So to solve this, I distribute, and this is going to give me 3.3 minus 0.0825x is equal to 2.4. So we get negative 0.0265x is equal to negative 0.9. And divide to solve for x. Round to 3 decimal places. You get 33.962 liters. So how much of each do we have? Well, we have 33.962 liters of 5.6% solution. And then compute the 40 minus x with this 33.962 value, and you'll see that we get 6.038 liters of the 8.25% solution. And those are the answers. Alright, question 18. Lisa can paint a house in 2.25 hours. Bart can paint the same house in 3.5 hours. If they work together, how long will it take them to paint 4 identical houses? So let's draw the table. So we have Lisa, Bart, and here we're going to have the rate at which each of them paints the house, the amount of time they're going to spend painting the house, and then the houses that they can paint in that time. So if Lisa can paint a house in 2.25 hours, that means her rate is 1 house per 2.25 hours. Same thing for Bart. His is 1 house per 3.5 hours. They're going to work together, which means they're going to spend the same amount of time working on painting the houses. And this is a rate times time problem. It's like distance, but instead of distance, it's houses painted. So we're just going to multiply going across. So it's 1 over 2.25t, and then 1 over 3.5t. And then together, so this is total, this needs to add up to be 4. So Lisa's contribution plus Bart's contribution is going to be the total 4. So we're going to add, and add, and that's a total of 4. Now this one's neat because both of them are factors with t, so I'm just going to factor out t. Oops. So t is equal to 4 divided by 1 over 2 plus 2.25 plus 1 over 3.5. And if you work that out, you get 5 hours and 5.478 hours. There you go. The other thing we needed to do up here is define the variable. And t is going to be equal to time painting houses together. Alright, question 19. A computer monitor screen is a rectangle whose length and width are in a ratio of 4 to 3. If the diagonal screen is 28 inches, what are the length and the width? Alright. So here's maybe what it looks like. Here's the diagonal, so that's 28. Now, the ratio of the length and the width are 4 to 3. So we're going to use a scalar. So we're going to have the length is 4x, and the width is 3x. And so x is equal to 1/4 the length. Okay. Alright, and since it's a rectangle and we have a diagonal, that means we have a right triangle in the upper part there. So we're going to use the Pythagorean Theorem. So we're going to have 4x quantity squared plus 3x quantity squared is equal to 28 squared. So 4x squared is 16x squared, 3x squared is 9x squared, and 28 is 784. 16 squared plus 9 squared is 25x squared is equal to 784. Divide both sides by 25 and you get 31.36. Take the square root and you get x is equal to 5.6. We don't use plus or minus here because x is 1/4 the length. We know the length has to be a positive number, so there's no negative for the x. So now we can compute what the length is. The length is 4 times 5.6 because it was 4x, and so that's 22.4 inches. And the width is equal to 3 times 5.6, which is 16.8 inches. Alright, lastly, number 20. The height in feet of an object tossed straight up from an initial height of h0 feet at an initial velocity of v0 feet per second is given by h is equal to negative 16 t squared plus v0 t plus h0, where t is the number of seconds since the object was tossed. A ball is tossed straight up from atop a building that is 150 feet tall with an initial velocity of 60 feet per second. The ball is tossed in a way so that it is over the edge of the building and is allowed to fall to the ground. So, write the model equation for the height. So part A, this would be h is equal to, we're just going to fill in this formula with the appropriate values. So it's negative 16 t squared plus the initial velocity, 60 times t, plus the initial height, 150. So that's the answer for A. B, how high is the ball after 4 seconds? So 4 seconds is a t value, so we're going to plug in t is equal to 4. So we get h is equal to 16 times 4 squared plus 60 times 4 plus 150. And if you work that out, you get 134 feet. And then C, after how many seconds will the ball hit the ground? So the ground is height 0. And so we're going to take the quadratic, set it equal to 0. I don't know if this factors or not, so I'm just going to go ahead and use the quadratic formula. So we're going to get negative 60 plus or minus the square root of 60 squared minus 4 times negative 16 times 150 divided by 2 times negative 16. If you work that out, one of the answers doesn't make sense. The other answer is 5.465 seconds. Alright, thanks for watching.